It's been 4 years since the end of the war. And today we send forth a vessel designed for battle, but now repurposed for peace.
Hey everyone, welcome back to Installation 00, and today we get back to the most detailed series and take an in-depth look at the UNSC Infinity, or at least the bits that aren't classified. Note that this is a complete overhaul of the original most detailed breakdown of the Infinity. To get right to the lore, skip to this time signature or the introduction chapter to skip my reasoning behind this re-upload, but I recommend, to avoid confusion, you stick with me here for a minute or two. I've remade this most detailed breakdown for a few reasons. One, I said when I did the original that it was not a complete breakdown, and that I would revisit it. Two, there were aspects of my normal ship breakdown process that I didn't perform on the Infinity, and it is only fair that I do so, mainly relating to the stem to stern analysis, which has been rectified in this video. And three, I'm simultaneously launching the Archive, a subcategory of the most detailed series. If you consider that when I do a ship breakdown, for example, most UNSC ships have fusion drives and titanium A armour and Mac cannons and nearly a dozen other features that are nearly identical from ship to ship. Rather than repeating the same information from video to video, I thought it better to highlight the differences that a respective ship may have to the others, and then refer you to the library or archive of many most detailed breakdowns relating directly to the specifics of these similar features. That way I don't feel like I'm giving you the same content but packaged up in a different way. You don't feel cheated by hearing the same stuff over and over. You get a good feel for the detailed breakdown in the main video, but if you choose to delve even deeper, the videos are there to satisfy that craving. Based on the popularity of this new concept, I may also make a UNSC Infinity Supercut, where all of this peripheral information is merged into a single multi-hour video. But we'll see. This will eventually encompass many other aspects of the lore than just ships, but everything's got to start somewhere. Just as it was with the original breakdown, there is so much lore that is yet to be explored or extrapolated, and as such, there is still so much left to find out. As I'm sure you're aware, the research that goes into a most detailed breakdown is immense, so they're not as common as my other video series, but when we do get one lined up, you can expect a level of detail here that you absolutely will not find anywhere else. In the research for this video, I have drawn information from the games and books including Halo 4, Spartan Ops, Halo 5, as well as Halo Warfleet, Halo Mythos, the official Spartan Field Manual, and the Essential Visual Guide, and referenced sites like Halopedia and Halo Waypoint to bring together as much information on the Infinity as possible. At the same time, however, in places where I have practiced knowledge, I have extrapolated additional information using principles of science, technology, engineering and mathematics in order to add layers of detail otherwise missing or only briefly touched upon. While some aspects of this breakdown are not necessarily cited in the lore, I have used these principles to inform my assumptions and estimations within a tolerable margin for error. And while at this time I am confident in its accuracy, as new lore emerges, I am willing to reconsider these points and adjust my views accordingly. Should this happen, further videos will be made looking at the specifics, in order to build a more complete understanding and referenced guide to the Infinity. Now with all that said and done, welcome to the Infinity. UNSC Infinity INF 101 is an experimental Infinity-class supercarrier of the UNSC Navy commissioned following the end of the Human Covenant War. Built in secret, utilising technology recovered from Forerunner and Covenant sources during the war, Infinity is the UNSC's largest and most advanced multi-role vessel to date. Infinity serves under the direction of Fleet Command and was originally captained by Andrew Del Rio and later Thomas Lasky. She is the current designated flagship of Expeditionary Strike Group 1 and serves as the ceremonial flagship for the United Nations Space Command. The first ship of her class, Infinity, was secretly deployed in combat in March 2553. On February 21st, 2557, the vessel was officially commissioned after being refit with technology that would add scientific and diplomatic endeavours to her capabilities. By February 2558, Infinity had a crew of 17,151 sailors, marines, ONI operatives and civilian personnel, as well as numerous adjunct members of the other UNSC branches and a number of 𝐎𝐵𝐺 specialists. Infinity may additionally embark an escort force of 10 internally docked Strident and later Analyst class frigates. As of October 2558, the primary shipboard AI is Roland. The ship's motto is Order et Faire, to dare is to do. It is worth remembering that much of the particulars of the Infinity and how she was built is still highly classified, so information at this time may be incomplete or missing entirely. However, I will do all I can to extrapolate within reasonable limits as we go. The ship was constructed in the Special Assembly Plant Concord located in the Oort cloud surrounding the Sol system, with construction beginning in 2544. The ship was designed by a team composed of Vice Admiral Elizabeth Sark, Commander Oscar Grayson, and Doctors Dana Wolf and Seda No Okuna. Secrecy was ensured by having workers permanently stationed there over several years, with a total communications blackout in effect. The ship's massive building expenditures, however, prevented ONI from keeping the Infinity a complete secret. Many senior members of the Admiralty, such as Rear Admiral Saeed Shafiq of UNSC Procurement, were fully aware of the ship's existence at the time of her construction. Eventually, the fleet took control of the vessel rather than the Office of Naval Intelligence. Captain Andrew Del Rio took command of the ship and her pre-commission crew years prior to the end of major hostilities in the war. though 𝐔�ห์𝖵𝐺 correctly predicted that Commander Thomas Lasky would eventually supplant Del Rio. As of March 2553, technology discovered on Trevelyan, a shield world located in the Zeta Doridus system, was planned to be incorporated into the ship. 𝐻𝐵𝐺 assistance in refining the ship's slipspace navigation capabilities in particular was expected to push the final construction milestones far ahead of schedule. Unlike older warships which had only areas such as a gym or hangar space for Marines and Spartans to train in, Infinity is the first known vessel to include a state-of-the-art virtual reality combat deck capable of replicating environments from across the galaxy, real or hypothetical, using a combination of holography, props and simulated sensory input fed through the Spartan's neural interface. Due to the classified nature of the Spartan program, much of this information is still classified. From stem to stern, Infinity has a length of 5,694.2 meters, or 18,681.6 feet, a beam of 833.3 meters, or 2,733.9 feet, and a height of 1,041.2 meters, or 3,415.9 feet. This makes her the largest warship the UNSC Navy has ever commissioned, surpassing previous record holders such as the Punic-class supercarrier. Among contemporary vessels, her length is surpassed only by the Covenant's 29-kilometer CSO-class supercarriers and the Sangheili 6.3-kilometer brigantines, though by foreigner standards she qualifies as a mere destroyer. For transportation throughout the enormous vessel, Infinity is equipped with high-speed tram systems. Her hull is composed of 4.9 meters of titanium A3 armour. I've covered titanium armour many times before, but this permutation is a newer variant and thus it stands to reason has some properties that are above and beyond previous iterations. The exact alloy of titanium is still unclear. Titanium A plating is the major quoted titanium alloy used by the UNSC, but there is no clarification on the exact nature of it. All we know for certain is that the primary titanium mined is a high-grade form of titanium called titanium 50. This simply means that there are 50 subatomic particles made up of 22 protons and 28 neutrons within the atomic nucleus, totaling the 50 subatomic particles, and that it is molecularly strengthened to more suitably fulfill its role as armour plating. I believe I can deduce more than this by its characteristics, material properties, and understood and established methods of metallurgy. There is passing reference that this permutation of titanium is ablative in nature, meaning that when hit by plasma weapons, material from the armour vaporizes, chips, or is otherwise eroded away from the surface to negate the penetrative effects of the projectile in question, carry heat away from the ship, and protect the inner, more essential and vulnerable areas of the ship by sacrificing sections of the armour local to the impact site. This may be where titanium A armour gets the A in its name, A standing for ablative. Obviously at this time, precious little information is actually available about the particular material properties of titanium A armour, so I have endeavoured to analyse it and proposed viable ways that titanium A armour could be developed. Obviously, if new law comes out that gives more information in this regard, I will revisit this assessment completely, and hell, I wouldn't be against 343 Industries themselves using my analysis to add to the law if they saw fit. But let's get to grips with titanium A armour. Given the described performance of the armour plating regarding its ductility, suggested atomic mass and density, its thermal properties as well as its shear strength and a handful of other parameters, I can say with a high degree of certainty that the alloy in question is an alloy called grade 38 titanium. This is where titanium is alloyed with 4% aluminium, 2.5% vanadium and 1.5% iron, which reduces the amount of vanadium needed as a beta stabilizer. The specifications of such is good cold workability and higher atomic density, leading to superior ductility, which enables the plating to locally deform when struck by a high velocity projectile, rather than cracking completely, but also being very tolerant to high temperatures before structural integrity is compromised. This at least ascertains the specific alloy and grade of titanium for the armor plating based on the law and the properties of specific alloys to meet the prerequisites of battleship armor plating. So, the specific permutation of titanium will be mined, refined from ore, and mixed with alloy materials in order to attain grade 38, and then forged into plates. There is more to it than just this. In regards to its molecular strengthening, I believe this can be achieved via an alpha-beta phase alloy. Various heat treatments as well as very precise purification processes all help towards the properties of this alloy. Let's explore alloy phases a little bit first. The phase is simply the term used to describe the atomic structure of the alloy. With titanium, atoms of titanium align within the metal into an either hexagonal close-packed crystalline structure, which is called the alpha phase, or a body-centered cubic structure, called the beta phase. The specifics of what phase the titanium alloy is in is highly dependent upon the heat treatments of the alloy, and the heat treatments themselves impart very specific properties into the alloy and affect the phase in turn. Titanium alloys are heat treated for a number of reasons, the main ones being to increase strength by solution treatment and aging, as well as to optimize special properties such as fracture toughness, fatigue strength, and high temperature creep strength. But it is also highly dependent on the alloy phase. Now, going back a bit earlier, I postulated that the titanium A armor is an alpha-beta phase alloy. Titanium alloys are divided into 4 classes: commercially pure, alpha, alpha-beta, and beta. Each class has distinctive characteristics. Pure titanium, although very ductile, has low strength and is therefore used when strength is not critical and corrosion resistance is desired. The alpha alloys are weldable and have good elevated temperature strengths, but cannot be dramatically changed by heat treatment such as tempering. The alpha-beta alloys are widely used because of their good combination of strength, toughness, and formability. The beta alloys are used where very high tensile strengths are required. Commercially pure titanium most definitely does not fit into the criteria of the in-game armor plating. Alpha alloys cannot be adversely affected by heat treatments, ruling out this phase for the titanium A armor, and beta alloys are only needed when high tensile strengths are required, and since tensile strength is a property of a material under tension or stretching, this doesn't necessarily meet the requisites of armor plating, whereby impact and shear strength are much more desirable. This leaves the alpha-beta alloys, which are metastable and generally include some combination of both alpha and beta stabilizers, and which can be heat treated, thereby adding additional desirable properties. By working as well as heat treatment of alpha-beta alloys below or above the alpha-beta transition temperature, large microstructural changes can be achieved. This may impart a substantial hardening of the material. Solution treatment plus aging is used to produce maximum strengths in alpha-beta alloys. Also, other heat treatments including stress relief heat treatments are practiced for this group of titanium alloys as well. So we now have our phase locked in. So to recap, we now have a titanium 50 grade 38 alpha-beta phase alloy for the principal material of titanium A armor. So now we'll look at the specifics of the heat treatments that the armor plating will go through to achieve the needed properties. Titanium alloy will be annealed, whereby the alloy is heated into the upper end of the alpha-beta range, held for a time, and then cooled very slowly. This also assists in recrystallization and serves primarily to increase the fracture toughness, ductility at room temperature, dimensional and thermal stability, and creep resistance. This would have the effect of making the plate much tougher and less likely to crack upon impact, while also ensuring it remains ductile enough to locally deform, thereby absorbing kinetic energy of an impact over a greater distance, time and area, while also ensuring that the plate maintains its shape and properties even when heated by energy-based weapons. Next, stress relieving is the treatment of a metal or alloy by heating to a predetermined temperature below its lower transformational temperature, followed by cooling in air. The primary purpose is to relieve stresses that have been absorbed by the metal from processes such as forming, straightening, machining, and rolling, all of which being processes the armour plating would likely go through in the production process. It will then be precipitation hardened, also called age hardening or particle hardening. It's a heat treatment technique used to increase the yield strength of malleable materials and relies on changes in solid solubility with temperature to produce fine particles of an impurity phase which impede the movement of dislocations or defects in the crystal's lattice. Since dislocations are often the dominant carriers of plasticity, this serves to harden the material. Now, to break this down, within any material there is a grain structure, which is effectively where the atoms of the material arrange into an ordered grid. Now, these ordered grids can be consistent throughout the entire material, a state known as a single crystal superalloy. Or, as with most materials, there will be small islands of ordered matrices of atomic structure, all bunched together into a disordered phase matrix. These individual islands, or crystals, are what we call the grain of a material, and where these grains meet is known as a grain boundary. And since these grains don't align perfectly, the atomic bonds at these grain boundaries is substantially weaker than the rest of the material, meaning that if the material does go under unusually high stresses, if there's any place that is going to fail, it's going to be at these grain boundaries. And while one workaround would be to make the entire material a single crystal superalloy, for plates as large as titanium A armour on the side of a ship, this would be impractical to say the least. An easier way to fix this is to introduce impurity into the phase matrix, basically small atoms of other stable materials, into these grain boundaries that effectively stop these dislocations between the grain boundaries from slipping. In a similar manner to putting a filler into a crack in a wall to stop the crack from spreading, impurities can be introduced to the dislocations in the grain boundaries to stop them from moving. The reason this is called age hardening is because, generally speaking, these impurities will be introduced naturally into any material over time. We're simply engineering it to happen under a much shorter time span. Further to this, titanium dioxide dissolves in the metal at high temperatures, and its formation is very energetic. These two factors mean that all titanium except the most carefully purified has a significant amount of dissolved oxygen. In fact, it could even be considered a titanium-oxygen alloy. Oxide precipitates offer some strength but are not very responsive to heat treatments and can substantially decrease the alloy's toughness. So another molecular strengthening technique that may be used by the UNSC may be the removal of oxygen and oxides from the alloy by use of deoxidizers or reductants. How the UNSC go about performing this task isn't immediately apparent. So now we have a deoxidized titanium-50 grade 38 alpha-beta phase alloy with age hardening. All of these processes and properties are currently very well established mechanisms of alloy production and processing that are used across the world right now. I would now go a step further, but at this point I implore you to understand that this is most definitely moving out of the realms of real-world techniques and very much into the hypotheticals of material properties under extreme conditions. While informed by known principles of science, it is still abstract enough to be worth mentioning at this point. But again, given that it is the 26th century in the Halo universe at the moment, it is entirely plausible that new techniques and technologies have come into place to allow what I'm about to extrapolate on to actually happen. The next thing I would suggest could go a way to fully fleshing out Titanium A armour is the implementation of gravitics to induce a super hardening and hyperdensity to the alloy in question. We already know that the UNSC and humanity at large have a good grasp of gravitics, or the control of gravity. They have gravity generators on ships, gravity generators in more modern repulsion drives, gravity generators to keep frigates hovering in atmosphere, and even anti-gravitic children's games, such as Gravball. It stands to reason then that there is a possibility of employing extremely powerful gravitic fields when forging materials to grant them properties and characteristics far in advance of their normal specifications. We have only ever created materials under the influence of the gravity of Earth, one standard G. But in extremely powerful gravitic fields, matter can achieve some phenomenal properties. Neutron stars are the collapsed cores of supermassive stars. Under the extreme force of gravity, matter is crushed so closely together that a single teaspoon of a neutron star would weigh around 1 billion tons. This is obviously an extreme case, but forging a material under tens of Gs or even hundreds of Gs could have adverse effects to the material properties. A good analogue of this is found in carbon. A crystalline form of carbon, known as graphite, is a very flaky, dull black metallic looking material with a hardness between 1 and 3 on the Mohs hardness scale. Under extreme pressures and high temperatures, graphite forms into diamond, a completely transparent, perfectly ordered crystalline matrix of carbon with a Mohs hardness of 10, being one of the hardest naturally occurring substances in existence. Using this analogue, whereby the pressure is replaced with artificial gravity gradients and the temperature is as a consequence of the material being white hot or molten while being forged, a titanium alloy could undergo a significant change in its material properties under these conditions. The only limiting factors being how much gravity can be generated and focused, not bridging the gap between hyperdensity and fusion, and the properties persisting even after the armour has been forged, applied to ship and cycles from immense artificial gravity fields to near 0G in space. Although there is yet another way that extreme properties could be achieved to a similar end, but without such extreme forces required, and that is through the process of internal crystalline tension. A Prince Rupert drop is a small bead of molten glass that is cooled extremely quickly in water. The outer surface of the molten glass cools nearly instantly, hardening and establishing its crystalline grain structure, while the centre of the drop remains molten for a time, now being insulated from the cold water by the now solid outer shell. As the core of the glass cools and hardens, it contracts, pulling the outer shell inwards, but since the outer shell has already solidified, it remains in place, instead undergoing an internal tension force, imparting a mechanical force on the glass's crystalline structure from the inside. The result is that the teardrop head of a Prince Rupert's drop can be struck multiple times with a large hammer and will not break. However, if the tail of the drop is broken, internal stresses release explosively, causing the drop to shatter instantly. Under the right hypothetical conditions, a section of armour plating could undergo a similar process and induce an internal tension within the crystalline matrix, while also purposefully working around the weakness of having these internal stresses exploited, resulting in a near explosive failure of the plate. I would suggest doing so would only be possible in a single crystal superalloy, whereby the atomic structure of the alloy would be a perfectly ordered matrix of atoms throughout the entirety of the material, and as far as cooling, it would need to be cooled, at least the outside, from white hot to close to absolute zero extraordinarily quickly for any of these properties to even have a chance at forming. Both the artificial gravity properties and the internal tension force treatments are completely hypothetical, and there is no supporting law to suggest that these are in place. They are just simply examples of how the material properties of Titanium A armour could be augmented to stand up to the punishment we see it take in universe, while still being seated somewhat in the principles of material science. Finally, for Titanium A armour plating, although not directly related to the material properties themselves, the space between the armour plates is filled with shear thickening fluids, which are non-Newtonian fluids, containing suspended particles of ceramic. When a shear force is exerted against the fluid, the particles within the fluid form an almost instantaneous crystalline matrix, hardening the fluid to 98% of the mechanical strength of the associated ceramic material in the blink of an eye, thereby acting as a liquid armour, the induced crystalline matrix now relaxing and returning to its normal viscosity nearly immediately afterward. This fluid also has an encapsulated healing agent to reduce sprawl from impacts and automatically seal hull breaches. This is all contained within a cellular hexagonal material that can be simply laid and attached to connection points within the inner hull surface. The plates are also generally embedded with thermal superconducting radiators to more efficiently transfer the heat generated by the ship into space. Unfortunately, this feature doesn't seem to benefit the ship at all in reverse. When the plate is struck by sufficiently large plasma weaponry, the plates heat up and, in particularly sustained attacks, can become molten and boil away. The radiators do not help in dissipating the heat taken on board by the plasma bombardment, and generally the plates radiate this heat back into space gradually. But this is also accompanied by the internal air temperature spiking considerably in areas close to the impact zones of plasma. In fact, in some cases, since atmosphere or air is more thermally conductive than the vacuum of space, plasma bombardment to the outer surface of a ship's hull can result in air temperatures inside, very close to the impact site, spiking to lethal levels, capable of burning the occupants almost immediately. It is also briefly referenced that tungsten may be layered with the Titanium A armour to augment its radiation shielding rating to a 5, and I assume make it tougher to kinetic energy penetrators and plasma weapons. There is still, even now, so much mystery surrounding Titanium A armour. In this video, I believe I have assessed the capabilities of Titanium A armour plating used on UNSC ships and applied reasonable principles to ascertain the specifics of this miraculous armour plating. Titanium A armour appears to be a Titanium 50 grade 38 alpha-beta phase alloy with age hardening, with the possibility of internal tension and gravitics being viable ways to further augment its properties. Again, should new law emerge that suggests otherwise, I will amend my assertions. And if 343 Industries are looking at adding to the law and looking at viable ways that they could do it, this assessment is certainly a way it could be done. The ship also possesses MJ-44N heavy dispersal field generator energy shields, making her the first UNSC ship known to be fitted with energy shield systems. The combination of armour and shields is strong enough to withstand direct impacts with a Covenant RCS class armoured cruiser while sustaining negligible damage. A quick calculation reveals some extremely impressive specs in that regard. The Infinity has a mass of 907 million metric tons, meaning when it rammed the RCS, which although it was moving perpendicular to the Infinity, their approach velocity was similar to the Infinity striking a near stationary object. The Infinity exited Slipspace and moved her entire length out of the rift before striking the RCS in approximately 4 seconds. This means her velocity at this point was approximately 1,423.5 meters per second. Putting her mass and velocity through a kinetic energy calculator gives us an impact force of 9,189,507.4 gigajoules, or nearly the same amount of energy as a 2.2 megaton explosion or 146 Hiroshima bombs detonating at the same time. The fact that the Infinity shields were still up after that impact says volumes to the energy shield's strength. On top of this, since the Infinity outweighs the RCS approximately 10 times over, it highlights exactly why she could plough through the RCS without so much as a shudder. Only at the end of the Human Covenant War were resources, facilities, funding and personnel made available to upscale the immensely successful energy shielding of the MJOLNIR program. This innovation leapt forwards in the peace following the war, leading to energy shield implementation across various assets of the UNSC, with the most impressive ones being shipborne energy shield systems. The energy shield emitters positioned across various points on the hull of the ship emit a high-energy oscillating electromagnetic field tuned to specific frequencies to enable the field to completely envelop the outer hull. It is likely, due to the powers involved and helped by the vacuum of space, that the emitters themselves are superconducting in nature, and more than likely the shield is assisted in its propagation across the ship's hull by superconducting conduits within the armor plating itself that effectively acts as routes for the energy shield to project along and bridge the otherwise immense gap between shield emitters. Very powerful electromagnetic fields can levitate even non-magnetic objects. The energy shield reduces the velocity of an incoming ballistic projectile to a near standstill. The sudden change in velocity, as well as the eddy currents induced by the field itself, induces extreme heat in the projectile, mainly due to its own internal friction caused by the sudden change in inertia, thereby causing the rounds to thermally expand and destroy themselves, or flash vaporize. This is not without consequence, however. The heat from this process, as well as the distortion of the EM field, induces a large amount of thermal energy which is carried by the EM field back to the emitters. The shield emitters are sensitive to too much heat, and once the shielding has taken sufficient damage, the emitters shut down briefly as a safeguard to avoid permanent damage. But it isn't a universal occurrence. Not every shield emitter will fail. Only the emitters nearest the attack are overwhelmed with thermal energy and shut down, but this causes the entire shield to fail due to the now incomplete shield geometry. During this time, the shielding fails and the residual electromagnetic energy around the armor plates bleeds off via high voltage static electrical discharge, showing the characteristic sparking we are all accustomed with. The pulsing we see from the shield emitters is caused by them attempting to start up again but being unable, until the emitters that have shut down have dumped their excess heat and can reinitiate the shielding altogether. This enables the shielding to completely repulse ballistic projectiles until the aforementioned shield failure due to the sustained fire and the build-up and backfeeding of thermal energy. In the case of energy-based weapons, this process is sped up due to the higher innate heat of an energy-based projectile, with overlapping effects from the projectile's own electromagnetism, causing the shields to fail more rapidly under plasma fire than ballistic. When considering the shielding of ships, however, the amount of energy that can be dedicated to a shielding system massively inflates the shield's resistance to damage. Adding more energy to the production of an electromagnetic field results in exponential increases in the field's strength. Electromagnetic field intensity is measured in a unit called a Tesla. So 1 Tesla is defined as the field intensity generating 1 Newton of force per ampere of current per meter of conductor. Some would argue that the unit to measure would be a Gauss unit. However, this unit is more suitable for small magnetic fields. When dealing with a ship or indeed MJOLNIR armor, the energies involved makes it more logical to reference the Tesla as the unit of measurement. We have seen precious few instances of UNSC shielding under stress in combat situations to get a plausible estimation of their strength. Bearing in mind that energy shielding is actually only a more recent occurrence in the Halo universe for the UNSC, happening majoritively post-war. The one instance I am immediately familiar with is that of the UNSC Infinity during its second tour at Requiem. During her exit from Slipspace, the Infinity had a direct collision with an RCS-class armoured cruiser, which completely obliterated the cruiser but left no discernible damage to the Infinity. Now, the Infinity has a mass of 907 million metric tons, meaning that when it rammed the RCS, which, although it was moving perpendicular to the Infinity, their approach velocity was similar to the Infinity striking a near-stationary object. The Infinity exited slipspace and moved her entire length out of the rift before striking the RCS in approximately 4 seconds. This means her velocity at this point was approximately 1,423.5 meters per second, which, for the record, is actually a ridiculously slow speed for objects in space, and in particular objects that are under power in space. But again, this velocity is based on the Infinity's entire length moving out of a slipspace rift in approximately 4 seconds. Now, putting this velocity and her mass through a kinetic energy calculator gives us an impact force of 9,189,507.4 gigajoules, which we can convert to newtons since 1 joule is equal to 1 newton of force working over 1 meter. So 9.18 million gigajoules converts to 9.18 quadrillion newtons. This is the first step of calculating the magnetic field strength in Tesla via the Lorentz force equations. We also have a velocity at 1,423.5 meters per second. We also have a vector of 90 degrees based on the impact of the Infinity against the cruiser, and the final variable that we need is the charge. Now, this is extraordinarily difficult to ascertain in any great degree of certainty. However, some reasonable assumptions can be made. Almost all of the most powerful electromagnetic fields humanity has ever produced here on Earth were done so with rectified AC to DC voltage around the 415 volt range, being in line with a free-phase AC circuit. The most powerful modern nuclear reactor, while currently offline, is the Kashiwazaki power plant, capable of producing just shy of 8,000 megawatts of energy. With the wattage and voltage integers, we can quickly calculate the amperage of this raw energy around 19,277,107 amps. So we now have all of the variables. Now, before we go any further, I acknowledge that is a significantly big jump. But there are real-world equivalents that I will use to justify this assumption in just a moment. But based on the incremental increase in power output of nuclear fission reactors since their inception to now, and assuming nuclear fusion follows a similar trend, with this extrapolated out to 500 years in the future, whilst simultaneously taking into consideration that humanity in the 26th century rates somewhere between a Tier 1 and a Tier 2 civilization on the Kardashev scale, or a Tier 4 on the Foreigner Technological Tier scale, I think although it is a significant jump in logic, it's a jump that's within the boundaries of possibility for the future development of energy generation technologies. Now, although most ships in the UNSC are powered by nuclear fusion, with all of this in mind, I expect that the output energy of a modern fission reactor, along with the principles of widely accepted electrical standards being adopted and utilised that far in the future, at least give us a ballpark figure for the charge to finish our Lorentz force equations, and arrive at a Tesla rating for the shields of the Infinity. But I'll justify this assumption in just a moment. So with the force of 9.18 quadrillion newtons, a velocity of 1,423.5 meters per second, a vector angle of 90 degrees, and our charge of 19.2 million amps being the only variable I feel is quite an assumption, we arrive at a magnetic field strength of 23.02 Tesla. Now, 0.3 Tesla is about the strength of your average sunspot. 1.25 Tesla is the flux density of a neodymium magnet. 1.5 to 3 Tesla is about the strength of modern MRI machines. 8 Tesla gives you the strength of the magnetic fields within the Large Hadron Collider at CERN, with 16 Tesla being sufficient to levitate a frog, or more accurately, diamagnetic levitation of the water within its body tissues. Yet, as per our calculations, the shield strength of the Infinity is around 93.02 Tesla. This puts the electromagnetic field strength within spitting distance of that of a typical white dwarf star, rated around 100 Tesla. This may seem outside of the boundaries of imagination, But truth be told, we already have created electromagnetic fields with the strength of 100 Tesla. One such example, located at MagLab's Pulsed Field Facility inside the Los Alamos National Laboratory in New Mexico, currently produces the highest non-destructive field in the world. Note the term non-destructive. Generally speaking, electromagnetic fields of this strength do one of two things. One, they either physically rip the magnet apart due to the strength of the electromagnetic fields, or two, the electromagnetic fields induce such a high amount of induced energy in the metal medium that it actually flash vaporizes the metal and it explodes. That being said, this particular 100 Tesla magnet is powered by 4 separate electrical circuits. 3 of these circuits comprise the large 100 Tesla outsert magnet, which is powered by a 1.4 gigawatt generator. Now this is interesting because this is a real-world example of the use of electromagnetic fields of the dizzying strength suggested by the Lorentz force equations, and lends credit to my prior conservative assumptions on power requirements and energy. Now my estimation was an 8000 megawatt power source giving 415 volts from a 3-phase circuit, and calculating the immense current from simply dividing the watts by the volts. This real-world example demonstrates that the outsert magnet, the one that actually generates the 100 Tesla, is powered by a 1.4 gigawatt generator, which is actually 6000 megawatts more than I conservatively estimated, and powers the magnet via a 3-phase circuit. You also have to remember that after the Infinity collided with the armoured cruiser and ended its whole career, the Infinity just kept going, and it seemingly didn't actually drop its shields completely, as there's no noticeable damage to the front of the hull of the ship. This means that these estimations so far made, being based on the actual impact force, would still only be the strength of the shielding needed to survive such an encounter. And with the shields still being operational after the collision, it is only logical to assume the shields are significantly more powerful than 93 Tesla. Indeed, if it even dropped the power of the shields by 50%, that would imply that the rating of the energy shields would actually be more akin to 186 Tesla. And on top of this, again, the magnetic field strength tapers off extremely quickly the further from the source of the magnetic field you get. So if the shields of the Infinity are emitted from shield emitters and there is a gap between the hull and the actual shielding, it is inevitable that the shields would be capable of immensely higher figures than 100 Tesla, if it only takes 100 Tesla to deal with the collision that we've seen. Now admittedly, I haven't been able to put an absolute surefire figure in place, but this at least opens the doors to what kind of range we're looking at for the strength of energy shields used by the UNSC. As more information becomes available, I will revisit this and amend any calculations as needed. The superstructure of the Infinity is still highly classified. The nature of her primary structure is utterly unknown, although it is assumed, given her size, that she maintains her structure through an extremely rigid and powerful skeletal structure that was likely designed by AI and thus has a more organic physical model and profile based on trillions of data points and calculated through countless generative iterations of the design to allow the structure to distribute the immense mass of the ship evenly over its length. This, of course, is merely conjecture, but given the size of the Infinity and the prevalence of AI within the UNSC, it stands to reason that AI would have a contributing influence on the design of significant and ruthlessly complex systems that are graded as Tier 1 importance to the ship as a whole. The ship's sublight power plant is an XR2 Boglin-Fields S81-X-DFR, a fusion-powered set of 1 primary and 2 secondary repulsor engines. This entire city-sized engine module took 15 years to design, build, and test, and is still heavily classified. While the particulars of these engines are classified, we can infer some information from other known engine permutations and characteristics. The actual powerhouse behind these sublight engines is an advanced nuclear fusion power plant. It is worth mentioning that the Pillar of Autumn was refitted with a prototype set of improved nuclear fusion engines that featured 2 smaller reactors around a larger one, which were capable of boosting the overall power output by 300% for a short time if needed, alongside the innovation of a laser-based cooling system utilizing a slurry of photons cooled to near absolute zero. It would appear, at least at face value, that this system worked well enough that it was scaled up and implemented for the UNSC Infinity. Fusion reactors powered by deuterium reactors makes up the main component of a ship's primary propulsion system, known as the fusion drive, which uses vector drive exhaust of fusion byproducts to provide thrust. It would appear, however, that the Infinity doesn't use a simple basis of vector drive exhaust for thrust, instead using the immense energy to power its repulsor engines, generating the immensely powerful tidal gravitic forces that provide the Infinity with her primary thrust. Fusion reactor engines are the primary source of propulsion for all ships within the UNSC, utilizing the basic principles of nuclear fusion, whereby atoms are fused together under extremely high temperatures and pressures in order to generate immense levels of energy, with the only byproducts of this reaction being huge amounts of energy, the generation of helium, and the generation of large amounts of heat which must be removed in order for them to remain active without overheating. Nuclear fusion is one of the most significant breakthroughs in energy generation technology, taking 2 atoms of deuterium, isotopes of hydrogen, and fusing them together under high pressures via very powerful magnetic fields. The result is a helium-3 nucleus and the release of immense amounts of energy, some of this energy being converted by a process called electrostatic direct energy conversion. Under normal circumstances, the heat released would be used to boil water, which would then turn generators for the purposes of energy generation, and any excess heat having to be dealt with a liquid coolant that is then ejected into space in order to keep the reactor cool. This liquid coolant limits just how much power output a reactor can have at any given time, meaning that the command crew, or more accurately the captain, has to have all due consideration to just how high he can run the operational temperatures of his reactor without inducing a meltdown, otherwise known as slagging the engines. However, as previously mentioned, more modern reactor engines use a process called direct energy conversion. The fusion reaction occurs within the massive reactor chamber within a highly charged plasma medium. A selective leakage port on the reactor chamber opens, and by means of magnetics and electrostatics, the ions and electrons in the plasma medium selectively leak from the reactor chamber and are directed into an expansion chamber. Here, the plasma medium containing the highly charged particles is guided and expanded in volume by a fan-shaped magnetic field that reduces the power density and converts the rotational energy of the reaction chamber to directional energy, suitable for energy conversion. The electrons are separated from the plasma stream and collected on an electron collector grid of varying potentials based on the variance in high and low electron fields. This forms the negative terminal of the power source. Next, the ions are decelerated by retarding electric fields. Kinetic energy is thereby converted to potential energy, and finally the decelerated ions are collected on a high voltage electrode that form the positive terminal of the power source. This method of converting raw nuclear fusion energy to usable electricity can be considered as a particle accelerator in reverse. The high energy particles in the chamber are decelerated to low enough speeds to be effectively and above all efficiently manipulated and converted. The vast majority of the rest of the energy created is directed to the thrusters in a process called vector drive exhaust. The drive system includes an exotic mechanism that utilizes high order manifolds to eliminate the otherwise devastating fusion backblast. This basically implies that if the amount of energy that is being forced from the engine's thrusters is sufficiently large enough that it actually backfeeds through the manifolds back into the reactor, the reaction itself will have a runaway reaction along with massive spikes in temperature, slagging the engines almost instantly. These high-order manifolds can be seen as the glowing rings and concentric patterns within the thruster nozzle. They serve to ensure that the massive amounts of energy the reactors produce and vector to the thrusters never builds up, backflows into the reactor, and allows any excess energy not able to exit the thrusters due to flow rate to be selectively leaked off via these conductive surfaces. When the Pillar of Autumn was retrofit with upgraded engines, it prototyped a new innovative technology to keep the reactors cool without the need for a liquid coolant, which included an upgrade cooling system which features a laser-induced optical slurry of ions chilled to near absolute zero, which was far more efficient than the typical method and removed the reliance on expendable chemical temperature-controlled substances. In essence, the amount of excess heat removed by the new system increases as the reactor's output did. This self-regulating and self-cooling power plant was critical in combat since it virtually eliminated a commander's concerns about overheating and slagging a ship's engines. Basically, the process of creating this laser-induced optical slurry of ions chilled to near absolute zero was powered by the very reactors themselves. This laser-induced slurry then cools the reactor chamber very, very efficiently, allowing the reactor to increase its power output still further, thus generating more of the optical slurry, thus cooling the engine still further. Of the limited amount of information of this optimized engine layout that actually backfed to the UNSC regarding the performance of these reactors in the Pillar of Autumn's final months, enough impressive performance characteristics were ascertained to convince the UNSC to use a more advanced version of this prototyped system with the flagship of the UNSC fleet, the Infinity. The UNSC Infinity features the same orientation of 1 primary and 2 secondary reactors. However, contrary to being simple nuclear fusion reactors, the Infinity boasts an impressive repulsor engine setup, using stacked tidal gravity generators which create asymmetrical gravity fields that push and pull a ship through space in the desired vector, all without the need for any reaction mass or conventional exhaust. Aside from the UNSC's nuclear fusion power plants, the Covenant use a technique which replicates the conditions inside the core of a star, using deuterium and tritium as the fuel source, which are isotopes of hydrogen with a nucleus that contains a proton-neutron pair and a proton-neutron-neutron trio respectively, where a normal, more common hydrogen atom known as protium has no neutron at all. Because of this method, it can be considered a purer, more natural way of producing energy, if a little uninspired. The Covenant's pinch fusion reactors generate energy by the use of artificial gravity generators that create highly focused and powerful graphitic fields which, as a causative effect, give a close approximation to the forces at work within the core of a main sequence star. The physical shape of the reactor, with its 2 cone-shaped gravity-focusing generators positioned one above the other, their tips in close proximity, allow the gravity field to be focused down from a larger macro area to an extraordinarily small micro area, facilitating the continued fusion reaction by literally pinching matter inside a very tiny gravity-reinforced area. This means that when the reactor injects a steady stream of deuterium and tritium, the particles immediately encounter this environment and act as though they were actually inside the core of a star. They are suddenly pinched and powerfully forced together, fusing them together into a helium-4 nucleus and a free neutron almost instantly, generating huge amounts of energy in the form of light and heat. The energy that is released is then used as the primary source of energetic excitation to energize a plasma medium that all Covenant technology seems to use as the basis of their energy source. The plasma within the reaction area is kept compressed by high-strength magnetic fields, ensuring the reaction can be sustained continuously. Regardless of these 2 different methods of which nuclear fusion has been achieved by the UNSC and the Covenant respectively, both reactions are nuclear fusion reactions and as such are one of the most powerful reactions known in the universe, and demonstrates the ability of both factions to be able to harness the very laws of the universe in order to power our immense devices. Alas, there are only 2 other reactions that are more powerful than this, and that is the quantum vacuum energy of the universe, mainly utilised by the Forerunners, and a matter-antimatter reaction which, although there is evidence of the existence of antimatter in the Halo universe, we've never actually had any lore regarding matter-antimatter reactions for the sakes of energy generation. This is a field I continue to watch with interest. Repulsor engines used stacked tidal gravity generators which create asymmetrical gravity fields that push and pull a ship through space in a desired vector, all without the need for reaction mass or conventional exhaust. A repulsor engine produces quantum fluctuations in its wake that are extremely hazardous to personnel and nearby vessels within its range, particularly when operating at high thrust. This is basically all that is directly cited in the lore regarding repulsor engines. However, by implementation of other fields of quantum mechanics and physics, we can explore the potential fundamentals behind a repulsor engine, all of which can be found in the archive relating to repulsor engines. Again, link is in the description. Translite power is provided by the Mark 10 Macedon Z prototype number 78720HDS mounted on a remote carriage. The latter is of Forerunner design and origin, capable of dropping out of slipspace with pinpoint accuracy. It is also capable of powering itself by drawing upon foaming vacuum energy, which powers it independently of the ship's power plants. As the alien slipspace drive is not compatible with UNSC standard power and data feeds, a series of engine module interlocks based on Covenant control restrictors, are fitted. Forerunners' understandings of the mechanics of slipspace far exceed that of the UNSC or the Covenant. They used small crystals embedded in their slipspace drives to manipulate slipspace, allowing for smoother transitions. They had a superior grasp of reconciliation, the ability to correct or otherwise manipulate the causal effects of slipspace travel. Forerunner ships are also extremely fast, as seen when the Mantle's approach was able to travel from the vicinity of Installation 03 to Earth in a matter of minutes. It is then reasonable to assume that the slipspace engines in the Infinity are capable of immense translite velocities, but are likely not being utilised to their maximum efficiency due to a lack of a full working knowledge of the particulars of the drive function and characteristics. The 𝐲-Fujikawa translite engine functions by creating ruptures referred to in some sources as wormholes between normal space and the alternate plane known as slipspace, also known as slipstream space or the 𝐲-Fujikawa translite space. This engine creates ruptures by using high-power cyclic particle accelerators to generate microscopic black holes. Because of their low mass, Hawking radiation gives them a lifetime of around a nanosecond, or potentially a little longer than a whole second, before they evaporate into useless thermal energy, of course. In that nanosecond, the engine manipulates them into forming a coherent rupture between normal space and slipstream. A major component of the drive is a set of slipspace capacitors, which have to be charged before a jump. The 𝐲-Fujikawa translite engine generates a quantum field which prevents the ship and its occupants from being directly exposed to the 11-dimensional space-time of slipspace, instead translating the ship's presence to the foreign physics of slipstream space and squeezing it through into the higher dimensions. Maintaining the quantum field requires an enormous amount of constant calculations, with larger vessels requiring significantly more such calculations than smaller ones. For example, the slipspace translations of a Phoenix-class colony ship require 4.3 quadrillion calculations of the quantum field per second. A human slipspace drive does not actually accelerate a spacecraft through slipstream. This is performed by the ship's conventional reaction thrusters. Thus, ships with more powerful conventional engines are also faster within slipstream. When active, a 𝐲-Fujikawa translite engine emits alpha and beta particles. The coordination and plotting of slipspace jumps, referred to as astrogation, requires an enormous amount of calculations which require a navigational computer or a dedicated AI to successfully conduct. However, the basic jump parameters can be calculated by a human. The elements of selenium and technetium used to manufacture the 𝐲-Fujikawa translite engine, human slipspace drives, are considered black boxes which are very difficult to repair or maintain after they have been activated for the first time. Dr. Halsey also observed that in the past, several technicians had simply vanished while maintaining and manually adjusting a drive. However, such adjustments were still often necessary by the late 25th century, as the superconducting magnets that align the drive's acceleration coils tended to drift out of phase, and the electronic systems designed to control them often malfunctioned in proximity to the drive core due to exposure, the warped laws of physics around the device. A ruptured slipspace drive can create slipspace splinters in normal space, eventually consuming the drive and the entire ship which the drive is placed on. Mechanical failures like slip termination preventable or STP can also occur with slipspace drives, usually resulting from poor maintenance. An improperly mounted slipspace drive can also result in a catastrophic accident. This was the case with the colony ship en route to the Cygnus system around 2550. As a result of a maintenance failure, the drive transported half the ship into oblivion, killing 700. When a similar slipspace rupture was induced by 𝐔𝐩𝐥𝐨𝐚𝐿 to destroy the long night of Solace in orbit above reach, it created an EMP effect that disabled all satellites within its range. The Covenant FTL drives, being more technically advanced than humanity, have numerous advantages in slipspace repulsion systems. While the 𝐔𝐩𝐿𝐴 engine is said to punch a hole between the realms using brute force, Covenant engines instead take a small rupture and delicately enlarge it with surgical precision. This allows the latter to execute far more accurate slips. Covenant slipspace drives are often referred to as jump drives. In addition to their more powerful thruster engines, it has been theorized by the UNSC that the Covenant drives generate several micro-jumps within a single slipspace transition to measure the dilation involved in a jump, allowing them to reach their destination faster. Covenant drives are also generally more flexible and powerful than those of humans. They have thrice been seen to execute in-atmosphere slipspace transitions, although the first time the drive in question was controlled by 𝐴𝐵𝐷𝖆, a human AI. In addition, Covenant drives can execute successful slips even if underpowered. Aside from this information, very little is known about the primary manner in which the Covenant execute slipspace transitions. Forerunners' understanding of the mechanics of slipspace far exceed that of the UNSC or the Covenant. They use small crystals embedded in their slipspace drives to manipulate slipspace, allowing smoother transitions. They had a superior grasp of reconciliation, the ability to correct or otherwise manipulate the causal effects of slipspace travel. This was useful when carrying out large-scale coordinated military campaigns, or simply moving across enormous distances. Forerunner ships are also extremely fast, as seen when the Mantle's approach was able to travel from the vicinity of Installation 03 to Earth in a matter of minutes. Forerunner ships rely on their energy shields to keep themselves during the journey, unlike UNSC ships which rely on just their armour. A slipspace flake, or a slipstream crystal, is the central component of a Forerunner slipspace drive. They are quantum-engineered crystalline devices, and were used aboard Forerunner spacecraft to modulate the ship's passage through the higher dimensions, being a major contributor to their markedly stable slipspace transitions due to how they mediate temporal and spatial anomalies inherent to many slipspace interactions. This reduces travel times by orders of magnitude over the crude alternatives used by less advanced species. All slipspace flakes were chipped from a central core crystal, the location of which was known only to the master builder. The exotic composition and slipspace interactions of the crystal were incomprehensible even to the Forerunners, and were never replicated. The Forerunner capital of 𝐴𝐵𝐷𝖆 had an entire hallway located near the council chamber, decorated with millions of spent slipspace flakes, some adorning the walls, and others built into rotating sculptures. In real-world terms, black holes, and in particular oscillating or rotating black holes, are a possible avenue for faster-than-light travel, in that if rotating fast enough, they could create a traversable wormhole or an Einstein-Rosen bridge, allowing the immense distances of space to be bypassed quickly. Particle accelerators like the Large Hadron Collider at CERN are capable of producing microscopic black holes that evaporate in an instant due to Hawking radiation. The aforementioned quantum mechanical magic would be capturing one of these black holes and manipulating it with quantum fields to stabilise it, and then force an entire starship through the rift and into the hyperdimensions beyond. The major issue in this is the energy requirement of such an engine. It would be greater than anything humanity can currently produce.
To the infinity.
As of February 2558, Infinity has an official complement of 17,151. This included 8,900 Navy personnel, 5,400 Marines, 750 ODSTs, 1,700 ONI agents, 480 civilian UEG personnel, 8 𝐻𝐵𝐺, and 24 Swords of St. members. These are often organised into a Marine Expeditionary Division and a drop battalion for the ODSTs, which are then subdivided into 5 task forces, each of which can operate independently. Infinity also houses hundreds of Spartan 4s led by Commander Sarah Palmer. The ship's S-deck, affectionately known as Spartan Town, is dedicated to their use. Additionally, 800 of Army and 200 Air Force assets were assigned to the ship during her second tour on Requiem. The Infinity is almost completely self-sufficient, boasting facilities and comforts normally only seen on colony support ships. Single deployment is afforded by 329 R-1295 launching systems for the M9407 SOEVs and 124 B-854 jettison bays for the M8823 human entry vehicles. Emergency escape vehicles include 8,900 SKT-29 Class 8 enclosed heavy lifeboats and 12,750 RLT-85 emergency shuttle pods. Mass deployment is realised through a large number of bays located throughout the vessel. Infinity has 275 Cat 1 primary bays, 140 Cat 2 secondary bays, 108 Cat 3 material deployment bays, and 10 Cat 8 subvessel deployment bays. The last of these each carry a Strident class heavy frigate or an Anlace class frigate. Infinity also houses 10 M510 Mammoths, 560 M12 Warthogs, 80 M820 Scorpions, hundreds of aerial vehicles, 8 D96 TCE Albatross, 150 F41E broadswords or D79 TC Pelicans, and an unknown complement of 𝐔𝐸𝐿1 longswords. Infinity is also equipped with sizable recreational areas, including a large atrium-like memorial park located under an enormous transparent dome. The park has a self-contained biosphere complete with plants and animal life, and has been said to surpass many natural parks on Earth in size. Garden plots and activity centres are also found here, with the ceiling being host to an artificial sky dome. Among other amenities, the ship contains a bar known as the Full Moon. For training purposes, several wargames training areas can be aboard. Among them includes the second largest military simulation and test environment in the human sphere. The science deck for the Infinity is home to state-of-the-art laboratories and research facilities provided by ONI and the Watershed Division. It is unclear whether Infinity has a permanent escort formation apart from her internally docked subvessels, although on occasion she has been accompanied by formations comprising of dozens of vessels. An escort fleet consisting of roughly 24 Paris-class heavy frigates and a dozen Autumn-class heavy cruisers accompanied Infinity on her first mission to Requiem. Though only 2 of the frigates are known to have arrived along with their parent ship, they may have been destroyed when the Shield World's artificial gravity well was activated. 11 Autumn-class cruisers, including Song of the East, accompanied Infinity at some point between her return to Earth circa July 2557 and return to Requiem in February 2558. At least 3 Vindication-class light battleships were dispatched to the planet along with Infinity during the UNSC's second expedition there. Infinity is equipped with a highly advanced sensor and holographic imaging suite derived from foreigner technology discovered on Trevelyan. The system uses a combination of various shipboard sensors and imaging from orbital drones to produce a hyper-accurate real-time image of planetary surfaces in the ship's holotanks, such as the bridge's main holotable. Infinity also features a 16-channel Slipspace Wavecom data links for superluminal communications. Infinity's aft sensor array is equipped with a long-range hyperscanner, which are an advanced type of sensor system typically mounted on Covenant warships. They are capable of providing extremely detailed information on any object in range, including internal scans and structure composition. Unfortunately, the sheer volume of data available overwhelmed the Covenant crews, and as a result, their workstations typically filter anything not of immediate tactical significance. The UNSC Infinity's application of bridge crew and smart and dumb AIs likely circumnavigates this overwhelming level of data and transmisses it into usable intel. The rear sensor array also features a Forerunner luminary, which is a Forerunner device designed to scan for and identify Forerunner relics. This is how the Infinity has been able to locate the remaining Halo rings as well as a dozen other Forerunner sites throughout the galaxy. Infinity's primary armament is 4 27-meter bore CR-03 Series 8 magnetic accelerator cannons capable of firing various sub-caliber rounds, cargo packages, and autonomous kill vehicles with specialized payloads. This is already insane proportions for a gun, and to top it off, it's considered more powerful than the orbital defense platform's Super Mach cannons. The ODP Super Mach fires a 3,000-ton ferric tungsten slug at 4% the speed of light, delivering a synonymous amount of energy to 52 gigatons of TNT, approximately the same as detonating 1,000 SAR bombers, the biggest nuclear weapon ever detonated here on Earth, at the same time. The bore of the Super Mach looks a little less than 2 meters. The quoted bore from the Series 8 is 27 meters, making it around 10 times larger. On top of this, a single ultra-dense round fired from one of these Machs made a crater 7 miles across on St. With a little more information regarding the particulars of the Series 8 Machs, that's as close as we're going to get at this time to lore-accurate information. It is worth noting that the continuous streams of energy we see the Infinity's Machs put out in-game is for cinematic effect, and doesn't represent the realities of what firing the Machs would actually look like. Infinity's primary armament is 4 27-meter bore CR-03 Series 8 magnetic accelerator cannons capable of firing various sub-caliber rounds, cargo packages, and autonomous kill vehicles with specialized payloads. This is already insane proportions for a gun, and to top it off, it's considered more powerful than the orbital defense platform's Super Mach cannons. The ODP Super Mach fires a 3,000-ton ferric tungsten slug at 4% the speed of light, delivering a synonymous amount of energy to 52 gigatons of TNT, approximately the same as detonating 1,000 SAR bombers, the biggest nuclear weapon ever detonated here on Earth, at the same time. The bore of the Super Mach looks a little less than 2 meters. The quoted bore from the Series 8 is 27 meters, making it around 10 times larger. On top of this, a single ultra-dense round fired from one of these Machs made a crater 7 miles across on St. Now, there are two ways we can find estimates on the destructive power of the Infinity's Series 8 Machs, given that there isn't much information other than what I've just said about the Infinity's Machs in the lore. One way is with the exact quoted lore and extrapolating information based on what we already know of Mach platforms, and the other is based on the observational evidence. I'm going to opt to do both, and we can look at the specs of each and decide which is more likely, and if we can't decide, an average of the two. So given that the Series 8 bore diameter is 27 meters according to the lore, and on the assumption that it fires at approximately the same velocity as the Super Machs, being 4% the speed of light or 12 million meters per second, we need to roughly calculate the projectile's mass. The round fired from the Super Mach is a 3,000-ton ferric tungsten slug measuring approximately 1.5 meters in diameter, and given a 4.3 to 1 diameter to length ratio for the rounds found in the Cairo station, 6.45 meters in length. If we now assume the Infinity's Machs uses the same material just scaled up, giving us a round that is 27 meters in diameter and 116 meters in length, that gives us a volume of 66,473 meters cubed. Now we need to know the density of ferric tungsten. 7,870 kilograms per meter cubed for iron, and 19,300 kilograms per meters cubed for tungsten, giving an average of 11,430 kilograms per meters cubed, assuming an even 50-50 alloy that makes a mass of 759,786,390 kilograms, or a little over 759,000 metric tons. 79,000 tons travelling at 4% the speed of light equals 54 quadrillion megajoules of energy, approximately 12,906 gigatons of TNT, otherwise known as 12.9 teratons. This is so massive I can't even substantiate the destructive power, but it puts it somewhere in the order of 253 times more powerful than the orbital defense platform's SUPERMAC. This is so massive, we need to put this through an impact calculator to find out the crater size before we reverse calculate the crater we have on 𝐔𝐸𝐿𝐽𝑒𝐿. The crater was said to be 7 miles across. It's difficult to say with exact certainty because there are factors like atmospheric thickness and pressure, the type of rock at the impact site, the exact composition of the projectile in question, but using a clever little program online that calculates the impact effects of a given asteroid on Earth, we can enter in the basic information of our projectile and find out what kind of impact crater this would produce. We have to make some adjustments, however, because the calculator only takes into consideration the diameter of the projectile and its density, so we need to convert the assumed projectile volume or mass into an appropriate spherical analogue. A sphere with the volume of 66,473 meters cubed would have a diameter of 50.26 meters. If we put this into our impact calculator with a density of 11,430 kilograms per meters cubed and an impact velocity of 12,000 kilometers per second, and assume the Infinity fired its Mach from directly above, being 90 degrees to the impact site, that would create a crater 27.6 miles or 44.4 kilometers across. This, of course, is 4 times larger than the claimed size of the crater caused by the Infinity's Mach round on 𝐔𝐸𝐿𝐽𝑒𝐿. So we can rule out the claimed size of the Series 8 Max as a viable way to predict its energy and destructive capability, and instead revert to using the observational evidence that we can then reverse calculate and find out the type of impact that would create a crater 7 miles across. From that, we get a sphere that is 15 meters in diameter with a volume of 1,767 meters cubed, giving it a mass of 20,196 metric tons, travelling at 4% the speed of light. From that, we do our calculations for kinetic energy and we get 1.4 quadrillion megajoules, or 347,959 megatons, or a quite reasonable 347 gigatons, much less than the ridiculous 12.9 teratons that we got from the previous calculation. However, there is more. We can also use the physical dimensions of the sphere, including its volume, to reverse calculate the size of the projectile in question within a tolerable margin for error. It is quoted that the Infinity Series 8 Max fire sub-caliber rounds, so they don't have to stick to the 27 meter bore and can go significantly smaller. If we use the cylinder's volume as 1,767 meters cubed and stick as close to our 4.3:1 ratio between projectile diameter and length, the closest we get is a projectile that is 8.08 meters in diameter and 34.4 meters in length. So from this we can now ascertain some specifics about the Series 8 Mach cannons on the Infinity. Each of Infinity's 4 Series 8 Machs has a 27 meter bore, from which it fires sub-caliber 20,000 metric ton ferric tungsten rounds measuring 8.08 meters in diameter and 34.4 meters in length, fired at 4% the speed of light, impacting with the force of 347 gigatons, or the equivalent of getting struck by 6.8 super Mach cannons from an orbital defense platform simultaneously. With little more information regarding the particulars of the Series 8 Max, that's as close as we're going to get at this time to law-accurate information. The SuperMac fires a 3,000 ton projectile at 4% the speed of light. This is a great place to start because not only do we have a velocity, but we also have a mass, and from these two numbers we can work out the kinetic energy involved. However, we also have to bear in mind that the velocities we're dealing with are relativistic speeds, and as such we will need to do relativistic kinetic energy calculations. The reason being is because the closer an object approaches the speed of light, the more mass it gains. It's an interesting relationship between relativity and mass, and is governed broadly by the famous E=mc² equation, and more specifically by the Lorentz equations. So given these equations, if we then put in the 3,000 ton projectile that the SuperMacs fire, we get 219,425,927,318,694 megajoules. That is an insanely large amount of energy. If we then convert that from megajoules through to gigatons of TNT, we get 52.44 gigatons worth of TNT. It's now relatively easy to understand how a SuperMac can gut a Covenant ship, shielded or not, from stem to stern. Now, it is claimed in the Halo Encyclopedia, however, that the velocity of the SuperMac is actually closer to 50% the speed of light, thus resulting in a significantly larger yield. However, the source in the reissue of the Fall of Reach still says 4%, and since this is a more recent and more consistent source, we will accept 4% as being the true figure until proven otherwise. While we're on the Fall of Reach, it is also quoted in this book that the SuperMac can actually destroy 2 Covenant capital ships outright and severely damage a third. This is interesting because we can use this to extrapolate some further details regarding Covenant ships. So if we take the 52 gigaton yield and divide this by 2.5, assuming the 2 ships destroyed and 1 damaged, we arrive at around about 21 gigatons, give or take. If we then apply this number to one of the smaller Covenant capital ships, being the CCS class battlecruiser, then that suggests that in order to kill a single CCS class battlecruiser, you need approximately 21 gigatons of TNT. This is interesting information to have because not only does it clarify what it takes to kill a CCS class battlecruiser, it can also be used as a backward calculation to find out the yields of other Mac cannon systems. The frigates, for example, have a projectile that weighs 600 tons. We have no specific information regarding the Mac cannons of cruiser-sized vessels, other than it takes 3 shots to kill a CCS class battlecruiser. From this, that means that we have to infer the weight of the projectile. Now, considering that the frigate is a 600 ton projectile and the SuperMac is a 3,000 ton projectile, if we estimated it somewhere in the middle, around about 1,400 tons, that makes the cruiser's rounds about twice as massive as the frigate rounds, and the SuperMac cannon rounds about twice as massive as the cruiser rounds. Now that we have an estimated weight for the cruiser Mac cannon rounds, and we know it takes 3 cruiser rounds to take down a CCS class battlecruiser, and we know that it takes 21 gigatons in order to kill a CCS class battlecruiser, we can simply divide that 21 gigatons by the 3 shots. It gives us a yield of the cruiser-borne Mac cannons of 7 gigatons. We can then put this back through the kinetic energy calculator with the estimated mass and the yield energy, and it gives us a velocity of 2.14% the speed of light. Now this is interesting because we know that both the frigates and the cruisers fire their Mac cannons at roughly the same velocity, so we now know a velocity for the frigate Macs, and we know that they're 600 tons in mass. From this we can then calculate the yield of the frigate Mac cannons, which is 2.96 gigatons, but let's round up to around 3 just to be friendly. While there is an array of 𝐎𝐵𝐺 platforms on the UNSC Infinity in the form of the Mark 2551 𝐎𝐵𝐺, there is precious little lore on the velocities, densities or energies involved in the firing of this weapon. With the earlier Mark 2488, however, we do have some established lore on its stats. Specifically, it is quoted in Halo the Essential Visual Guide that the 2488 𝐎𝐵𝐺 is capable of firing a 15cm ferric tungsten slug with up to 1.1 gigajoules of kinetic energy. This is great because we have a round size, a round material, and the kinetic energy. We need to establish the round's mass, and then we can use this with the established kinetic energy to calculate the velocity. with some rather simple assumptions. If we assume the round in question is a solid 15cm diameter cylinder, as denoted by the term slug, being a solid ballistic projectile, that gets us started. We need to also know the round's length, and we can estimate this by looking at the ratio of diameter to length of known projectiles. One of the most common rounds in use both in real life and in the UNSC is the 7.62 by 51 NATO round. The actual bullet projectile of this round measures 7.62mm in diameter if you ignore the jacket, and 33.3mm in length, giving a ratio of 4.37 to 1. If we round down to, say, 4.3 to 1, we can estimate the 𝐎𝐵𝐺's projectile to be around 64.5cm in length, given its diameter of 15cm. The round material is said to be a ferric tungsten, basically meaning an alloy of iron and tungsten. The metal consists of anywhere between 70 and 82% of tungsten, so again, if we estimate 75% tungsten and 25% iron, we can now estimate the mass of the projectile. A cylinder of tungsten with an estimated diameter of 15cm and a length of 64.5cm would have a mass of 193.7 kilograms. However, only 75% of the projectile is tungsten, so if we subtract 25%, that equals 145.2 kilograms. The same projectile in iron would equal 81.7 kilograms. However, only 25% of the projectile is iron, so again, if we calculate that to be 20.4 kilograms by taking away 75%. Now, if we add these two resulting factors together, we get a ferric tungsten projectile that measures 15cm in diameter, 64.5cm in length, with a mass of 165.6 kilograms. The projectile has the kinetic energy of 1.1 gigajoules. We can reverse calculate the velocity from the mass and kinetic energy, and what we get is 3,644.8 meters per second, or around 8,153 miles per hour, or 13,121 kilometers per hour, or quite simply Mach 10.6, making this projectile hypersonic and more destructive than 6,000 50 cal BMGs being fired simultaneously. Now we have this information, we can use it as our base level stats to look at the other coil guns on UNSC vessels. And we start that with the M870 Rampart. This is a point defense weapon system utilized by warships of the UNSC, typically as part of a shipwide defense network. Each 870 gun, or Rampart, is a fully automated hull-based turret emplacement, typically consisting of a barrel of twin or quad-mounted 50mm rapid-fire coil guns and a targeting scanner. Point defense guns such as these are used for the engagement of incoming threats, including the warding off of strike craft and the disruption of plasma torpedoes. Each emplacement actively switches between subcaliber armor-piercing sabos or proximity detonation fragmentation shells based on threat analysis of its current target in order to maximize effectiveness. M870s are most commonly mounted on frigates, including the Charon-class light frigates, Stalwart-class light frigates, and Trident-class heavy frigates. However, they are also utilized on Gladius-class heavy corvettes, Halberd-class destroyers, and even the Epoch-class heavy carrier, making them a relatively common fixture across the entirety of the UNSC fleet. If we use our base level stats of the 𝐎𝐵𝐺 as a reference point, we can make some conservative assumptions on the Rampart. A 50mm projectile translates to 215mm in length given our 4.3 to 1 ratio for projectile dimensions. Though the material of the projectiles vary due to its two different projectile types, the proximity detonation fragmentation cells can be somewhat ruled out if we want to know the kinetic energy, leaving only the subcaliber armor-piercing sabos. Subcaliber means that the diameter of the projectile is less than the bore of the weapon. Similar rounds have a ratio between the bore diameter and the penetrator of 4.8 to 1. One example is the much larger M829-A3 discarding sabo round that has a penetrator diameter of 25mm but is fired from a 120mm barrel. That makes the penetrator of the Rampart around 10.4mm in diameter, and we'll assume the same 215mm length due to the gun being a coil gun, and thus no need for a shell or propellant. The UNSC make heavy use of ferric tungsten in their projectiles, so we will assume the same material is used as with the 𝐎𝐵𝐺. That gives us a projectile mass of 247.2 grams. If we assume a similar muzzle velocity of around 3,500 meters per second, since this is argued as the ideal muzzle velocity for kinetic energy penetrators, we get a kinetic energy of 1,514.1 kilojoules, or 116 50 cal BMGs, which is scary in and of itself, but when you consider that the Rampart can be a quad-mounted arrangement with rapid-fire capabilities, it gets to insane levels of destructive capability super quick. Most frustratingly, after this point, lore and information regarding the remaining naval coil guns is sparse, to the point that it's even lacking caliber, velocity, projectile properties, and practically all other variables to be able to be used to implement reasonable calculations on the specifics of the gun power and operation. Nevertheless, in the interests of being inclusive, this is all the information I could find on the remaining naval guns. The M910 Rampart Point Defense Network is a point defense system utilized by the UNSC Navy on its warships, and they're primarily used to shoot down fighters and missiles. The UNSC Pillar of Autumn was actually equipped with 18 of these guns, and the Autumn class heavy cruiser is equipped with 6 of these guns. It's a bit curious that the upgraded, newer version of the Autumn, which was actually directly based off of the original Pillar of Autumn, only has 6 when the original had 18, but I digress. These double-stacked Ramparts fire 50mm high-explosive rounds, making its destructive capability a little more difficult to calculate because we don't know the properties and statistics of the explosive package within the rounds, or even get close to inferring it alongside the different materials the round itself could be made of, but it's reasonable to assume that since this is a later version of the M870 Rampart, it's more destructive. Next in line is the 𝐿11A2R1 deck gun. In 2520, the Phoenix-class colony ship UNSC Spirit of Fire was outfitted with 10 such weapons. During the Human Covenant War in 2531, these weapons were often used to provide orbital fire support for the ship's crew. During the Battle of Entrin Harbourage, these cannons were used to defend against a Covenant CPV-class heavy destroyer, as well as numerous Spirit dropships and their Banshee escorts, while the ship's Marine and Spartan complement fended off borders and repaired the drive core. The guns are quad-barreled, however the bore is difficult to estimate, and on top of this, the exact projectile, whether it's sub-caliber or not, is almost impossible to ascertain. As such, until more information is available on the specifics of these guns, very little can be inferred aside from the obvious aesthetics. The Mark 55 Castor naval coil gun is a large naval autocannon used by the UNSC Navy after the Human Covenant War. It is capable of being loaded with a variety of specialised ammunition, including experimental shield-piercing shells. The Strident-class heavy frigate has 5 of these turrets, 3 of which being paired with 2 Mark 57 arena point defence guns in a quick-shot configuration. Again, with little more than aesthetics and no specified calibers, muzzle velocity or otherwise, very little can be inferred about this gun. The M66 Sentry was mounted on the Epoch-class heavy carrier and Autumn-class heavy cruiser. The UNSC Pillar of Autumn was also retrofitted with them in preparation for Operation Red Flag. We know basically nothing more than that about the M66. The Mark 33 Spitfire is armed with 2 rapid-fire naval coil guns for offence. After its refit for Operation Red Flag, the UNSC Pillar of Autumn was equipped with 8 of these turrets. The Mark 40 Spitfire is a refinement of the older Mark 33, featuring a higher muzzle velocity, improved tracking speed, and better accuracy than its predecessors. Unfortunately, we have no information on the specs of the predecessor or this newer version of the platform, so we can make no extrapolations on the specifics of this gun. The gun mount is apparently several tons lighter thanks to it being armoured with a new formulation of the Titanium A armour, while still maintaining the same level of protection. The Autumn-class heavy cruiser sports 4 of these coil gun batteries to complement its MAC. The Mark 15 breakwater coil gun appears to be the largest coil gun battery used on UNSC ships, before of course making the transition over to MAC platforms. Its massive 3-barrel arrangement invokes images of the 16-inch Mark 7 United States naval gun used up until the turn of the 21st century. and in absence of the MAC platforms on the ship could be considered its main guns. Aside from this gun being obviously massive and likely extraordinarily powerful, precious little information is actually known about this battery. A shame, to be sure, because I would have really enjoyed calculating the properties of this gun at length. But alas, there is still time for this information to come to light from lore in the near future. One can only hope. Infinity boasts a significant missile network that can be implemented for ship-to-ship combat and anti-air defense, orbital gunfire support, or marine forces, among other uses. Emplaced throughout the ship are 1,100 missile pods of 3 types: Archer, Rapier, and Howler. The M42 Archer missile provides secondary armament for Infinity with 350 pods of 24 missiles each. Additional missiles include the M75 Rapier 250x30 missiles and the M96 Howler 500x20 missiles. Close-in defense against enemy missiles, fighters and boarding craft is the primary mission of the M965 Fortress Point Defense Network, a series of 830 70mm automatic cannons. Infinity is also equipped with a network of Mark 2551 Max, a network of M85 Scythe anti-air turrets, and a network of M97 Lance missile pods mounted on the dorsal hull. Infinity also carries a sizable complement of Variant 5 Havoc nuclear warheads. Hull Section 1 is dominated by the Infinity's 4 Series 8 MAC cannons, with its barrels, capacitors, ammunition and feed systems and supporting decks making up a third of the mass of the forward 1 kilometre of the ship, with the bridge being slung directly underneath. It is reasonable to assume the captain's quarters are also in this area, and an array of communications hardpoints protrude from the front of the ship, as well as many point defense systems arranged in overlapping fields of fire. These are continued for the entirety of the surface of the hull of the ship. There is a heavy-duty hardpoint on the lower port and starboard side of the ship, used to dock with stations, tethers and other ships and allow the movement of freight to and from the Infinity. This is where much of the ship's provisions will be taken on board. From here there is access to a heavy lift crane system for the sakes of localised logistics, and direct access to the ship-wide rail travel system to enable the relevant provisions to be moved quickly and easily to the areas of the ship that they are intended for. Hull Section 2 is almost entirely dedicated to crew quarters. This is hardly surprising given that the Infinity was originally conceived as a kind of lifeboat, for if humanity lost the war with the Covenant. The Infinity was, and is, intended to house, support and play host to close to 20,000 people. With such a massive population, provisions had to be made as to the accommodations of so many people. The Infinity is almost entirely self-sufficient, with facilities and comforts normally only seen on colony support ships. She also contains an entire deck dedicated to Spartan operations, colloquially known as S-Deck. This contains all the accommodations for the Spartans, personnel facilities, separate R&R facilities, separate mess halls, barracks, armoury, training areas, including the second largest military simulation and test environment in the human sphere. This area of the ship is crisscrossed with vast travel systems and support engineering and service corridors for the general maintenance of the ship's systems. Hull Section 3 houses the 10 sub-vessel bays in the belly of the ship. Inside the 10 internal vertical hangar bays, Anlace or Strident class frigates can be found suspended in their docking clamps, ready to be launched at a moment's notice, bolstering the Infinity's already impressive military might with its own personal escort fleet of frigates all outfitted with MAC cannon systems and nuclear capabilities, and even the possibility of energy shielding when it becomes available. Traversing throughout Hull Section 3 is some of the most heavy-duty superstructural support beams that have ever been constructed, some of the largest having a cross-sectional area of nearly 60 feet squared. 18.2 square meters, and some of the longest vertical beams, being more akin to the ribs of a conventional vessel, measuring close to 700 meters in length. This rib-like structure can be observed in the cutaways shown in Halo Warfleet. This means, hypothetically speaking, somewhere inside the ship, either along the keel or the spine, there could hypothetically be an absolutely humongous primary structural beam, but for now we can only hypothesize of this. Nested between the two rows of 5 sub-vessel bays is the Marine Expeditionary Units, a Marine Division and Drop Battalion of ODSTs being permanently assigned to the ship. These troops are organised into 5 task forces, each of which can operate independently with fully supporting facilities, barracks, training areas and amenities. The �𝐸𝐸 launch bays are similarly styled to that of the Marathon class heavy cruisers, with pods being held in rows of cradles on a rotating rack, all accessed by suspended gantries. To the aft of this are the 8 massive shuttle bays of the Infinity, 4 on the port and 4 on the starboard, stacked in a 2x2 arrangement. These shuttle bays feature heavy-duty armoured blast doors and energy-filled systems to contain the atmosphere within the ship even when the blast doors are open, allowing ships and personnel to operate within the bays at all times, even as ships such as Pelicans and Albatross dropships are arriving and departing. A full hangar and surfacing area for the Infinity's complement of dropships and vehicles can be found nested in and around these 8 shuttle bays. Around the midline are much of the military operational areas of the ship. Here you will find supplementary hangar bays as well as dropship launching rails capable of accelerating a Pelican to takeoff velocity in seconds. Many of the armories, cryobays, locker rooms, gyms, mess halls and the like can also be found in this area. Although this hull section isn't all work. Dominating the upper hull surface is an immense cylindrical domed structure, visible from nearly all angles, and nearly as wide as the ship itself. This is the Infinity's Memorial Park, located under an enormous transparent dome that looks out into the depths of space. The park has a self-contained biosphere complete with plants and animal life, and has been said to surpass many of the natural parks on Earth in size. Garden plots and activity centres are also found here, with the ceiling being host to an artificial sky dome. While the very top of this dome is a clear window out into space, the panels lower along the sides of the dome are massive displays capable of producing realistic skyboxes, with clouds, blue skies, different colours of dawn and dusk, as well as virtual weather fronts. This immensely impressive area is highly prized and utilised by the crew of the Infinity for R&R time, as well as shipwide events and entertainment. Hull Section 4 plays host to the science deck, where state-of-the-art laboratories and research facilities provided by the Office of Naval Intelligence and the Watershed Division can be found. This is also where the ship's Wavecom data links can be located on the lower hull surface, enabling superluminal communications. This aft section of the ship also contains the ship's reactors and Slipspace Engine, all accessible and serviceable by qualified engineers and technicians via a maze of gantries, platforms, interconnecting corridors, and maintenance access ways. It is also here that the immense engine module interlinks between the UNSC standard power and data feeds and the Forerunner engine module via Covenant control restrictors can be found. And underslung to this is the powerhouse of the Infinity, the city-sized Forerunner engine module that pushes this immense ship through space at sublight velocities. But it's worth noting at this stage that the performance we have so far observed of the Infinity may not even be the finished article, due to the inherent inconsistencies and inefficiencies associated with mating 2 incompatible technological systems via a poorly understood and ill-implemented third technological buffer. The engines, for example, are Forerunner. The ship is human in design. To mate the pair of these incompatible systems, the UNSC made use of Covenant control restrictors to bridge the gap between the UNSC and Forerunner technology. But the control restrictors were poorly understood and ill-fitting systems when used by the Covenant. All they really knew is that they seemed to work better than whatever they were doing beforehand. Even with AIs like Roland on the task of perhaps incrementally overhauling those systems, they're still significantly limited in nature by the very hardware of the system. So basically the performance the Infinity is actually doing is as a consequence of a 3-step conversion process, mating 3 distinctly different types of technology together with all of the inherent inconsistencies and waste energies associated with such a system, and with the Covenant parts being suboptimal at best. It is possible then that if the UNSC let a few AI and maybe some 𝐎𝐵𝐺 loose on those systems, they could perhaps overhaul the entire system and make the UNSC to the Forerunner components relatively seamlessly, boosting overall performance by at least 33%, being the utter removal of the flawed Covenant restrictors. This could hypothetically result in the Infinity being capable of immensely faster sublight velocities, and slipspace velocities more akin to that of the Anodyne Spirit, the Forerunner key ship at the centre of High Charity, which itself was capable of jumping the distance between Installation 05 and Earth in mere hours. But again, this is merely conjecture based on observations. And finally, at the very tail of the ship is the aft sensor array containing hyperscanners capable of mapping the surfaces of planets from orbit with extreme levels of detail, and a Forerunner luminary fully facilitating and enabling the Infinity's primary mission, which is the continued search for and discovery of Forerunner relics across the galaxy. As things currently stand, there is very little additional information about the Infinity that I have not already discussed or is already directly observed in-game. I will of course endeavour to revisit the Infinity as more information is declassified and divulged to me, so this most detailed breakdown is far from complete and may yet even become a series. Again, if you want to see a multi-hour supercut of this video with the relevant archives all edited together, let me know in the comments down below. Be sure to subscribe to keep up to date with future information regarding the flagship of the UNSC, as well as tons of other technologies from the Halo universe. Thanks for watching. Sticky comments down below, I look forward to what you have to say. I just want to give a quick shout out to my patrons and YouTube members 𝐵𝐸𝐿 the Silent Cartographer, Siphonic Storm and Todd Morrison, my Tier 0 Transcentients, Brian Sebastian, Red Sea, Darian, Stalker of the Realms, Falcon X003, Alvin, Mr. Fell, Flaming Halo, Starlight, Legions Lost, Josh, Kyle, the TG7, 𝐃𝐚𝐭𝐞, Schneidish, Leon, Ignizzle, Chris Spartan 118 and Cooper, the Holders of the Mantle, my Glorious Reclaimers, my Loyal Metarchs, and all the other patrons and members who have jumped aboard to support the channel. Much love to you guys, thanks so much for your support. It's keeping things happening and helping the development of the channel and future awesomeness in a big way. If you like Halo lore discussed to insane levels of detail, hit that subscribe button and the little bell icon so you're told the second a new video hits the shelves. Be sure to support us on all major social media channels, including Discord, and if you really love the channel, consider heading over to Patreon and supporting the channel over there, or jumping on as a channel member. It would mean the world to me and affords you loads of great bonuses and perks, while also helping work towards some awesome stuff in the near and distant future. Take it easy everyone, and find peace in the domain.